All right. I guess I'll kind of just go through my notes, and then I can help out with homework after I do that. And if you guys have any questions, feel free to speak up. Let's start here. So there wasn't really any like crazy stuff in the intro. So the first thing I took notes on was 4.1. Basically, there's a couple of like times where we have to make assumptions about the consumer. So these four will come up a couple of times. So the first thing is we're talking about like their preference, so like what the consumer wants. We have to assume that they have a preference, number one, and that they don't have like they don't like not care, you know. I mean, there's ways to show that they don't care with graphs, but you want to know that they can choose one or the other, basically. The second thing is, for most goods, more is better. So like if I think the example it gives is if I like had a car, if I was buying a car, and I was buying it because it's a safe car, then it would be better for me if there was an even safer car. So more is better, like in most cases. These are just like general rules. They're not for every situation, but it's like I said, it's an assumption that we make. This one's kind of this is one where like they make it more complicated than it needs to be, and it's really like it's really what am I trying to say? I don't know. It's more complicated than it needs to be. So if A is better than B and B is better than C, then A is better than C. You know, that just kind of makes sense, you know. And it doesn't apply always, but it can be applied in that moment. Like if I like Walmart better than Target and I like Target better than HEB, then it makes sense that I like Walmart better than HEB. So, and then the final thing is the more a consumer has, the less likely they're willing to give to get more. So what that means is like, if I have the option between buying apples or bananas, and I already have 100 apples, I would give away like 10 of my apples to get even one banana, because I just have so many apples. Like I have no bananas. Bananas are worth more to me than apples just because I have so many. So that's where you kind of get this like curve, and we'll get into it later. These rules are going to come up again when you're looking at graphs. They're going to like explain some of these graph shapes. So it's good to like I said, most of it's common sense, but it's good to like kind of have an idea of it. So consumer preferences are ordinal, which means you can rank them, but you can't like put a number on them, if that makes sense. So you can say like, you know, Walmart, Target, HEB, but you can't say like Walmart is 20% better than Target and 40% better than HEB. You know. So it's you can only put a rank on it. You can't put a number on it, if that makes sense. Utility. This one came up a lot during the homework. It's just how satisfied the customer is. So we get these things called utility functions. That's this line right here. And what this is, so economics is kind of the study of choices, right? And you can think of this graph and these axes as like choices that people were making. So choice number one is, okay, how many friends do I want living near me in the building? Choice number two is the apartment size in square feet. Okay, so if I get a 1,500 square foot or 1,000 square foot apartment, that's pretty good. So I'm okay with only having 3 friends. But if my apartment is only 500 square feet, then I'm going to need 10 friends to make that, this is like, it's how good I would feel, basically. So like this line, any point on this line where those 2 axes intersect would be like the same amount of feeling good, if that makes sense. So like I would feel the same amount of good if I had 10 friends living next to me. If I had a 500 square foot apartment, I would feel the same here as I do here. Okay. The next thing that's going to come up a lot is marginal. All marginal means is like one more. So marginal utility is how much happier you would be with one more of that thing, if that makes sense. So if it's like, if you're trying to find the marginal utility of something, you would say, okay, I'm already this happy. How much happier am I going to be? It's the difference between how happy you're going to be with it and how happy you're going to be without it. It's the happiness from one more thing. Okay, indifference curves. So these are based on the more is better thing. So that's rule number 2. And you can figure out which one gives more utility. So these lines, this is one utility curve, indifference curve, and these are like different options you can have. So like this is if I were to shop at HEB, this is if I were to shop at Target, this is if I were to shop at Walmart, whatever. And each of these have like, you could think of it as like better deals, if that makes sense. So let me see if it has something better in the book. All of these graphs I got from screenshotting the book. So if you're looking for, I can also post these notes in GroupMe if you guys want them. But basically, the more out or up you go, like the further right, or the further on the x-axis or y-axis you go, the better the utility curve is going to be. Okay, so this is the best happiness. This is second best, third best, fourth best, and least happiness. Okay, same thing over here. This is the best, and then this is the worst. Okay, so when you're given 2 utility curves, you always want to be on the outside one. That's going to give you the most happiness, basically. And then you see like different shapes. That's spelled wrong. So basically, these are like the 2 extremes that an indifference curve can be. And it comes with things that are called substitutions and complements. Okay, so up here, or actually, I'll pull up one. What does it have on here? Okay, so tortilla chips. So it's a 12-ounce bag of tortilla chips or a 3-ounce bag of tortilla chips. If I'm going to the store and I'm there to buy tortilla chips, I don't really care if it comes in 3-ounce bags or 12-ounce bags. It's whatever's cheaper, right? If I can get 4 3-ounce bags for the same price as the 12-ounce or one 12-ounce bag, then it's not going to matter to me. It's just whatever's going to be cheaper. So like either way, whatever I spend my money on doesn't matter as long as I get the same. Okay, so that's why these are flat, right? I would, if I could only buy 4 bags of 12-ounce tortilla chips or 16 3-ounce bags with my money, then I could be anywhere in the middle, or I could buy all 4 bags of the 12-ounce or all 16 bags of the 3-ounce. Anywhere along this is going to be where I'm most happy. But like I said, it doesn't really matter because it's the same amount of chips, right? And it doesn't really, like, it doesn't make a difference. Where it does make a difference is like left shoes and right shoes. Like, it wouldn't make sense for me to buy more left shoes than right shoes, right? So you always buy them in pairs. And you can't really have one without the other. So if I buy 2 pairs of shoes, if I buy 2 left shoes, then I could be right here and only buy one right shoe. But like I said, the more further right you go and the further up you go, the happier you're going to be. So you want to be on this end of the, you want to be on one of these utility curves. So if I buy two left shoes, then I could be kind of happy but not really happy because I'm on this first curve, or I could be really happy because I have two right shoes to go with it. So, like I said, the main goal is to be as far on the utility curves as possible. I'm even happier if I buy three pairs of shoes right here, okay? But if we're looking at these as measures of happiness, I'm the same happiness if I buy, three right shoes and two left shoes, or three left shoes and two right shoes. Buying that additional left or right shoe doesn't really matter unless I get the next, like the other shoe. Like only the pairs matter, if that makes sense. So like if you're not going to get a pair, then it doesn't make sense to get anything at all. And then you can see some like this where it's like sometimes it'll change. So remember, this is the perfect substitution. So this would be if you're on like a budget constraint or something like that. And you're buying either bananas or strawberries, right? If you're on a budget constraint, you're buying one or the other, then it doesn't really, at least for me, it doesn't really matter if I get one or the other. It's just going to be whatever's cheaper. I want some fruit. I'm not that picky. I'm going to get whatever's cheaper. Okay, so that's going to be this line because they are perfect. Well, you see, it's a little bent, so they're not completely perfect substitutes, but it's really close to this line. This one has a little bit more of like a curved or an angled shape, so you can tell they're more of a complement. Okay, so like, yeah, I'd buy bananas, but I would give up a little bit of bananas to have some strawberries, right? And then my best utility would probably be right around there. So now we're going to add in, where is it at? The budget. So this will come in later. This one should be pretty easy to understand. So you have, again, two choices that you can make. The first one, you can either buy burritos or you can buy lattes, right? And your budget is $50, okay? You also have three more assumptions about it. So income is fixed. You can't just go get a loan and get more money. Goods have a fixed price, and you don't get any benefit from saving money. So those are the three assumptions you make with this graph. But anyways, if I have $50 and burritos cost, where is it, $10? Looks like it. Yeah, burritos cost $10. Then I can buy 5 burritos with all my money, right? Because 5 times 10 is 50. Now lattes are $5, so I can buy 10 lattes, so I have $50, so I can buy 10. And I can buy any combination upon this line, right? So if I want 2 lattes and 4 burritos, I can buy that, or I can buy 4 lattes and 3 burritos, anywhere along this line, and I will spend all my money on all lattes, all burritos, or somewhere in between. And these can kind of be put over each other to find utility, right? So, like I said, this is our budget constraint, right? So anything to the left of this line is feasible. You can afford it. Anything to the right of this line is infeasible. You can't afford it. So I can't have anything up here. I can't have 6 burritos. I can't have 10 lattes, or I can't have 11 lattes, and I can't have 5 burritos and 10 lattes at the same time, right? So anything to the right is infeasible. You can't afford it. Anything to the left, you can afford it. You're good. Okay. So you can put these graphs on top of each other, and you can kind of see where they overlap, right? So anything to the left, she can afford. So she can afford to be at B, she can afford to be at C, and she can afford to be at D, right? And she can afford to be at A as well, right? She can't afford to be at E, and she can't afford to be anywhere else outside of this green line right here. because she can't afford it. So how do we choose what point is going to be the best for her? Like, where's she going to get the most utility, the most happiness? So D, she's not spending all her money, right? So she won't be getting the most happiness. She is on an indifference curve, a utility curve, but she's on the low utility. Like, she wouldn't be getting that much happiness. B and C, she's spending her money. That's good. But she's not getting a whole lot of happiness on it, right? She's the same amount of happiness here, buying a bunch of burritos and maybe one latte or something. But she's not getting a whole lot of happiness out of it, because you see she's on the first utility curve, the unhappy curve, right? So she wants to be on the farthest up and the farthest right curve possible. So ideally that'd be here, but no part of this line intersects with this line, right? So we're going to go to this one and see if there's anything. A right there, utility is maximized when we get half lattes and half burritos. Are you guys understanding this? That's all the notes I took for this chapter. Did you guys have any questions? If not, you can like throw a thumbs up or whatever. Sick. All right. Awesome. So I'm gonna go over the homework right now. The one thing I would really encourage you guys to do is, like, if you haven't tried it already, try it. I will share this. Copy link. Actually, anyone can view copy link. I'm gonna share these notes in the GroupMe, and you guys can let me know if that works or not. But yeah, like I said, definitely try it. Try the homework by yourself with these notes before you like just copy my answers. Because like obviously I'm not going to be there to help with the test, so it's important that you guys like understand kind of what you're doing. But yeah, I'll go over these and how I solved them. You can see I didn't get perfect scores on these. It was kind of, I mean, one of these was like this one was like a rounding thing. I put 10.61 and it didn't. Oh well, I'm a little salty, but whatever. Okay, so let me get this up. See if this is going to work for me. Yeah, that. Awesome. Okay, so I have kind of like scratch notes over here, just so you guys can see how I solved it. So firstly, suppose that Juliet and Andrew each consume 2 popcorns and 2 slushies. Who gets the most happiness for his or her movie snacks? So happiness, utility, same thing, right? Oh, I guess I should start with the calculating utility. So we have the formulas here. So what's Juliet? Oops, that's an eraser. Juliet equals P times S, and then where is it? Andrew equals P plus S. And those P and the S are just the units of popcorn, units of slushies. So you just plug these numbers in. So for Juliet, that's going to be J equals, I have 1 popcorn and 1 slushie, square root of 1 plus, oh no, sorry, it's 1 times 1, my bad. Times 1 times 1 is 1, square root of 1 is 1. So Juliet's utility is 1. Andrew's utility is just 1 plus 1 added together. So A equals 1 plus 1 equals 2, right? And then same thing for the other one. So you guys can plug these in. I don't think I need to do simple math in front of you guys, but that's how you get those numbers. So B, this one is the one that I did quickly and I didn't really think about it. So in the book, it says, what does it say? Did I take notes on this? No, I didn't take notes on that. Oh well. There's somewhere in here where it says you can't judge one person's utility based off somebody else's utility. So like you can't say that like, oh, where is it? Oh well, it's somewhere in here. But I had to like go back and look at it. So you can't just look at this and say like just because Juliet's utility is 2 and Andrew's utility is 4 doesn't mean that like Andrew had more fun than Juliet. So Juliet's ranking would be she had the most fun here, second most fun here, third most fun here, right? Because 3 is more than 2 is more than 1. And then same thing for Andrew, you can rank them, but you can't compare them between the two people, right? So think of these as separate. These numbers are totally arbitrary, which means they don't mean anything to each other, if that makes sense. They only mean something within this column. They don't relate to each other outside of this. So he's not having twice as much fun as she is right here, okay? He's just having the least amount of fun, the second most amount of fun, and the most amount of fun here, if that makes sense. Okay, this one is just another calculation on, what's it called? Using the utility formulas. My iPad keeps going to sleep. Okay. So Juliet is 2 popcorns and 3 slushies, so I shouldn't erase those. Square root of P times S. And then 3 slushies. So 2 popcorn and 3 slushies. So we're going to do 2 times 3, which is 6. So the square root of 6 is, let me see, QRT 6, 2.449. Let's just call it 4.5. Okay. And then what happens if she eats another cup of popcorn, right? So instead of 2 popcorn, she's going to have 3. 3 times 3, square root. It's going to be the square root of 9, which is equal to 3. Okay. And what it's asking for is what's the approximate marginal utility. So again, marginal utility is what it's like the change in utility. So if you guys have taken another math class where it's like delta something, delta is the change in. So if you see like the triangle, which is delta, and then a u, so delta u, that's change in utility, marginal utility. So what's the marginal utility of her getting that extra thing of popcorn? So that's going to be the difference between these two. So 3 minus 2.45 equals what, 0.55? Yeah, 0.55. Okay, so what is the approximate marginal utility if she instead drinks another slushie? Okay, so we're back here. Square root of 2 times 3. What if instead she takes that out and gets 4 slushies? Well, that's going to be square root of 8, right? 2 times 4, that's square root of 8. It's like 2.7 maybe? SQRT 8. 2.828, so 2.83. 2.83. Okay, and then we're still subtracting that from, she drinks another slushie. Yeah, so we're subtracting the 2.5 because that was the original one. So minus 2.45, and that was 0.38. So again, marginal utility, what is the difference from one more, right? Andrew consumes one popcorn, one slushie. Another popcorn increases utility by 1 unit. When Andrew consumes 8 popcorns and one slushie, another popcorn will again increase it by 1 unit, right? So the it's asking which one of those 4 rules that it violates. It's the one where it's like, the more I have, the less I would give for another one of that thing, if that makes sense. So if I had like 10 popcorns and you offered to trade me, 3 popcorns for 1 slushie, then I would do it. But Andrew wouldn't, because he values popcorns and slushie exactly the same, no matter how much he has. So we don't expect that of most people. So that's one of the things he violated, was that like, the more you have, the less you'd be willing to give up. Am I saying that right? The more you have, more a consumer has, the less they're willing to give to get more, if that makes sense. So the less you're willing to give of the other thing to get more. And then Juliet's utility function appears to violate the same assumption. This is false, because she doesn't value them. Meeting's gonna end in 10 minutes. Yikes. Okay, I'm gonna speed run this. This is false because she doesn't value them the same when she has more of one thing. So if she has like a bunch of one thing, she would give away, if she had like 10, she would give away like a couple of it to get one or something of the other thing. Speed run. Okay. Same thing here. Current utility, it gives you the formula right there. Just plug the numbers in. I think it's like 4 times 2 and then 2 times 4. So it's like 8 plus 8, 16. Marginal utility of another pencil, additional pen. Again, same thing with marginal utility. This is, so the utility she gets out of 1 pencil is 4. It's right there. And the utility she gets out of 1 pen is 2, so it's right there. So utility of 16, so 1 pencil is 4, 6 pens is 12, so 4 plus 12 is 16. That's the same level of satisfaction. 3 pencils times 4 is 12, 2 pens times 2 is 4, 4 plus 12 is 16 again, so same level of satisfaction that we started with. This is the, what's it called? The budget constraint graph. So if she has a certain amount of money, how much money does she have? Oh well. But this is the budget constraint graph. It shows that she can either buy 1 pencil and 6 pens, or 3 pencils and 2 pens, and she would have the same amount of utility. So since she would have the same amount of utility at all of these points, and it is a really flat graph, you can find that they are substitutes, so it doesn't really matter to her. They're not weighted the same, but like, she would trade the same amount of pencils for pens if she had 1,000 pens or if she had 10 pens. It would still be worth the same amount of pencils. The MRS, this one's kind of wacky. All it is the slope times -1. So the slope here is rise over run, that'd be a rise of 2 over a run of 1, so that's 2 over 1. But as you can see, it's a negative slope, so it would be like -2. But then you multiply by the -1 just so this value can be positive, and you get 2. It's kind of weird, but it's what they do. This one you're practicing doing the budget constraints. So how you find these? He has $240 per week. Music costs 12 items. So if he only bought music, he could buy 20 music. And if he only bought fireworks, he could buy 30 fireworks. So the slope, pretty easy, rise over run, not too shabby there. Same thing here. It's important to note that if somebody's budget increases, the slope doesn't change, okay? So this slope, no matter how much money he has, is always going to be the same, right? If the cost of one of these changes, that's where the slope changes, right? So if the cost of music changes and now I can only buy 20 music with, what is it, 240 bucks, then that's when the slope would change. But if the budget changes and the cost of things doesn't change, then the whole line moves and the slope stays the same, if that makes sense. So that's this one. So the prices relative to each other didn't change. The budget changed. Okay. Question 4. Income on fishing units. There's a price of 2. Okay, so optimal number. So you can see here in this right here that she values each of them the same, right? So L is raised to the same exponent as G, and this is lures and this is guitar picks, right? So we want to spend the same amount of money at each point, okay? So wait, you know where the rest of this list? Yeah, they did. That's why I got this first one wrong, because I put 10.61 and then it didn't like that. But yeah. So she values these the same. She wants to spend the same amount of money on each. She has $30. That means she's going to spend $15 on each. Okay. Guitar picks are $1 each, so she's going to buy 15 guitar picks, and lures are $2 a piece, so she's going to buy 7.5 of those. Okay. How much utility does this combination give her? You just plug it into the utility thing. That's the calculation for that. So, I'm sure you guys already know this, but anything raised to the 0.5 power is the same as doing a square root. So 7.5 raised to the 0.5 power times the square root of 15 is this 10.606. If you guys want to get it right the first time, make sure you only round to one decimal place. I didn't see anywhere where it said to do that, so I just kind of had to figure that out. But yeah, 10.6, and then if the price of guitar picks doubles to $2, how much income must Prissy make to maintain the same level of utility? Okay, this one is a little tricky. Let me pull up my thing. I have 3 minutes. It's gonna be awesome. Speed run. Ooh. Okay, so utility is gonna be 10.6 equals, and then so we have 10.6 here. This is gonna equal so the square root of L and times the square root of G. Okay. So what do we know? We know that, we know that guitar picks doubled to $2. So both of the things are $2 now. Okay. So the amount of money we're going to spend on them is the same, right? Because she values each of them the same. So if we're spending $40, then we're going to spend 20 on each and 20 on one, 20 on the other. Since they both cost the same, we're going to buy the same amount of each, if that makes sense. Okay. So L equals G in this, right? And with that, you can say that this is the same. This is the same as L times G. And with this substitution, gosh darn it, man. Let me just unplug this. You can just say that L times L, because G is the same thing as L. And then this is just 2L. Or no, not 2L. L squared. And so squared takes out the square root, and you're just left with L. So 10.6 equals L. So what is L? L is the amount of lures that I'm getting. And since L is equal to G, then G is also 10.6. Okay. So if I'm getting 10.6 lures, so lures at 10.6, and they're getting charged $2 for them, and then G 10.6 times $2 each. then you get, what is it? You should do 10.6 times 4, and then you get 42.4. Okay. This should really be 10.6 times 2 plus 10.6 times 2, but it's 10.6 times 4. And then you get this. So, yeah. This one's kind of wacky. Geez, a minute. Okay. So it's the same thing with the overlapping budget and what's it called? The other one, utility curve. The interior, corner, and exterior solutions. So exterior would be impossible. Interior would be anywhere on the curve, and corner would be at these 2 points over here. So this is the corner solution. This is an interior solution. The capital M is marginal utility. The P is, what was it, the price? Pretty sure this is price. Okay. And you can see where it intersects, that's where you're gonna buy. I don't know how to explain this better. I have less than a minute left, so if you guys have any questions, feel free to message me in GroupMe. But other than that, I guess I'll see you guys around or in class or something. But yeah, that's all I got. So let me know if you have any questions. Yeah.